In this program, we'll turn on each pixel of the LED strip a different color, creating a rainbow effect. Anytime we use the LED strip, we want to include the LED strip.h library. Including this library gives your program access to special functions like setPixel and draw that are exclusive to the LED strip. We also need to name the LED strip. I've named mine strip because that's easy for me to remember and easy to type. And we need to complete this LED strip function, which has 3 arguments. The first argument is how many pixels are there on our LED strip. The second is which pin of MakerBoard is plugged into the green wire of the LED strip. And the third is which pin of MakerBoard is plugged into the blue wire of the LED strip. There's no code inside the void setup function, but we still need to have it here with an opening and closing curly brace for our program to run correctly. Inside the void loop is a for loop. The for loop has 4 main parts. First, there is a variable that we create and give an initial value to. Second is a condition that's checked before the for loop runs. Third is a change to the variable that occurs after the code between the curly braces runs. And fourth is the code between the curly braces that runs when the condition of the for loop is true. In this case, we're creating an integer variable with int, and that means our variable can only have whole number values, no decimals, and giving it a name of I and a starting value of 0. I is a really common variable name to use when you're just counting how many times a for loop is running. The condition for this for loop is I less than 15? If that's true, the code between the curly braces will run. Inside this for loop, we have a setPixel function. The setPixel function has 2 arguments. The first one is which pixel we want to light up. This number can range from 0 to 14, but here we're using the I variable to stand in for that pixel number. So this is going to change each time the for loop runs. The second argument of the setPixel function is a color value that's going to show on our pixel. This is a number between 0 and 299, but here we're using I times 20 to change that color value for each pixel. The reason I'm using times 20 is because we have 15 pixels on the strip and 300 color values we can use. So 300 divided by 15 gives us 20. And this means we'll have an even spread of all our color values across all of our pixels. The .draw function sends our setPixel data to the strip and displays it. And the delay function with an argument of 100 delays the code here for 100 milliseconds before the for loop ends and I++ runs, increasing the value of the I variable by 1. Let's see how this program is going to run once you have everything set up on your MakerBoard. We'll create this I variable as an integer and start it at 0. 0 is less than 15. So the code between the curly braces will run, setting pixel 0 to a color value of 0, because 0 times 20 is 0. We'll have a delay of 100 milliseconds, and then I++ will change the value of I from 0 to 1. The condition will be checked. Is 1 less than 15? That's true, so the code between the curly braces will run again, with the pixel 1 being set to a color value of 20. Another delay of 100 milliseconds, and we'll reach the end of the for loop, so I++ will run again, and I will change from 1 to 2. 2 is less than 15, so the condition is true, and the code between the curly braces runs again, setting pixel 2 to a color value of 40. This is going to continue until I equals 14. Then Pixel 14 will get set to a color value of 14 times 20, which is 280. And after a delay of 100 milliseconds, the for loop will see its closing curly brace, and it will increase I by 1. So I will go from 14 to 15. 15 is not less than 15. So the code between the curly braces will be skipped. Then the code will move to the end of the void loop with this closing curly brace, and it's going to jump back up and reset I to 0 and start running the for loop again. You'll notice that nothing changes after the LED pixels have been all lit up. That's because all this program is going to do is overwrite the color values to the same pixels again and again. If you wanted to clear off the strip after lighting up all of the pixels, you could use the strip.clear and strip.draw functions to clear out the strip after everything had been lit up and start lighting the pixels one at a time again.